Hi, I'm Doug Newcomb. I'm a retired federal employee who's had about 30 some odd years of experience with desktop GIS, and I'm going to give you a quick presentation on the point sampling tool in sampling large raster and vector datasets in QGIS. So QGIS, it's an open source desktop GIS, and it's been around for 20 years. There's also a server component, but we're not going to be looking at that today. It has a Python plugin structure, and there are about 2,100 plugins currently available in QGIS 3.14. The QGIS Point Sampling Tool plugin has been around for a few years. It's in the default plugin repository, so you just can use the tools in the GUI to install it. We'll be going over that in a little bit. GitHub site, which actually has the source code for the plugin, is on the URL on the screen. And this plugin allows you to simultaneously sample data from multiple raster and vector layers for comparison. Saves everything in a vector layer in the attribute tables, and allows you to assess disparate data sets quite quickly and accurately. And it scales well with very large raster data sets. So how do you install it? First you open up QGIS, you go up to the plugins drop down, click on manage and install plugins. Then within that menu you start typing in the name of the plugin you're interested in this case point sampling, and you'll see point sampling tool come up. You click on that, click on install plugin, and it puts a nice icon here on your toolbar, and you're ready to go. So how do you use it? Well, you load all the layers that you want to sample into your canvas. The layers must be in the same projection or coordinate reference system, and then you need to click on the point sampling tool icon. And then you give you a list of all the layers and attributes that are active, as in the boxes checked so they're displayed, and you hold the control key down to select multiple layers and attributes for analysis. Then you type in the output layer name. It defaults to a geo package, but you can also do a common separated value or shapefile as the output. Then you click on OK and it does the analysis. In this case, I've got a layer which is the mean ground of the LiDAR data points for coastal North Carolina. Actually, I'm sorry, this is the actual DEMs from the state of North Carolina by county mosaic together into a VRT. And the point layer you have on top are survey points from USGS that are checkpoints for the elevations that are derived from the LiDAR ground points. And you also see the county layer. And if you look on the right, you'll see the point sampling tool dialog, and you see all the vector attributes within the checkpoint layer, the vector attributes in the polygon layer, and then you see down at the bottom different raster layers that are being selected as well. Then you put the output vector layer, and then you click OK, and the analysis is done. So when you get it done, this is the attribute table from the point layer that's created, and as you can see, it has values that you selected, the attributes you selected to be output, and it has a sampled value at that point for each one of them. Alright, so as I said before, it works on raster layers, virtual raster layers, vector layers, and one limitation is they have to be active and visible in the canvas before you can actually select them in the point sampling tool. So let's do a short demo. So let me get out of this, and then hey, here's QGIS. Let's go ahead and do our plugin and manage and install plugins, and let me get rid of the text here so you can actually see it in action. Point sampling, as I type, it narrows down the selections for you. Click on Point Sampling Tool, click on Install Plugin, and it's installed and ready to use. So there's that icon that I mentioned on the toolbar for the Point Sampling Tool. Now here's our county boundaries. There's the checkpoints that I mentioned. You'll notice they go outside of North Carolina into Virginia as well. And then we have the NC Coast dataset. This is a virtual raster table, which is a VRT, which is a way of mosaicing raster layers without creating a copy of the data. It creates an XML index of all the data and allows you to do analysis and visualization and treat it as if it were a regular raster. We'll be going over that creation a little bit later. This one is a mean ground layer that is the mean ground at a 3.125 foot resolution for all of coastal coastal area of North Carolina and up into Virginia, where the estuarine areas intersect that connect to the North Carolina estuarine areas. This is part of a DTM creation that I'm doing for the coast of North Carolina in my copious spare time. And the final one here is the actual draft of the DTM that I've been working on, and we will be using that in the analysis as well. This DTM draft is 125 billion pixels. The mean ground layer, since it goes a little bit farther down here, has 128 billion pixels, and the virtual raster of the county DEMs from the state is 111 billion pixels. These two are virtual rasters, whereas this one down here is a GeoTiff of 100 gigabytes. All right, so we've established all that. So now let's go on to do our analysis with our point sampling tool. So we click on the point sampling tool, and as I showed you in the screenshot before, you just go through using your control key to say, okay, what do we want? We want the unit identifier. Let's get the Z meters and Z feet for each one of those survey points, and then we'll get the county name for the county boundary polygon layer, and then we'll just get all three of these raster layers. And let's browse to where we want to put it. Let's chuck it in videos because I don't have anything in videos on this machine. We'll just call test survey samples. All right, I leave it GeoPackage because I like GeoPackages. They're really flexible. And just say OK. So now you can see from the status bar on the bottom that we have 1,447 survey points that are in this area. I think I'm missing a few in that part of that Virginia, but for our purposes today, this will be fine. And as it's going through for each point, it's sampling what the value is for each of the vector and raster layers that we have in this displayed on this map canvas right now. And it's done. So let's close that out and let's open our attribute table. And as you can see here, we have our feature IDs, we have the unique identifier for each one of these ground survey points. This is the elevation in meters, this is the elevation in feet to NAD 83 2011. County name, you see a bunch of nulls here because these are up in Virginia. NC Coast, also a bunch of nulls. There are a few on the edge in Virginia that were caught by that. And then we see the that's the elevation in the from the North Carolina DEM. This is the elevation from the mean ground, and this is the elevation in feet from the hydroflattened DTM. That's the draft, and you can compare them directly to here. In this case, we're going to compare the mean ground. You click on that, and you sort things, and you see we've got null points here, 18 nulls. So but everything else has a data for it. So basically, almost 99% of the checkpoints have data in the mean ground value raster. So let's go ahead and we're going to do a calculation. We're going to do standard error calculation. So let's go ground SE is what we're going to call it. We're going to make this a real number. And then we'll go here. Let's put a parentheses in first, and we're going to get the value of Z feet minus the mean ground value. Close that parenthesis, and then we're going to square the result, and that will give us the standard error for each point. So there we go, standard error. As expected, the nulls are still null, but there's the standard error. So we're going to save that, and we're going to stop editing mode, and then we're going to go down here to instead of checkpoints, we're going to the test survey samples, and then we go mean ground SE, and let's sort of stretch that up here so we can see a little bit better. And our mean standard error is 0.111296 feet. So let's pull up our calculator, and we're going to take the square root of 0.111296. I'm sure you're all anticipating if I get that wrong. And that's going to give us a result of 0.336 and some odd feet. And we're going to multiply that times 30.48, which is the number of centimeters per foot, and that gives us an RMS error of 10.16, call it 7 centimeters. Considering your target vertical accuracy for your LiDAR is 10 centimeters, that's looking pretty good. All right. So now let's stop that. And I did mention the VRT thing, the virtual raster table. That is something that can be easily created. Let's look at the mean ground layers. I said that was a VRT, so let's do a quick list of GeoTiff files that I have in the mean ground directory. Do a word count -line, nice little bash command, and that tells us that we have 81 separate GeoTiffs in that directory. Okay, and if we just do ls-alh star.tiff, and then I'm going to just get the first 5 values for that. There we go. So that tells us that tells you the different sizes of the rasters. Actually, I wanted to do LTH, so that gave a better variety. So, and you can see that the sizes vary from several gigabytes to a few megabytes for some of the smaller areas. So as we said, we have 81 files, and we want to make a single raster layer out of that. So what we do is use the good old buildvert and call this test mosaic dot VRT star dot tiff, and that doesn't work. Star.tiff. All right, and we go there. Oh, and it helps if you spell Goodle, right? There we go. So there we go. Now that took very little time to do, and this has now created a VRT file. And as I said, this is just an XML file which ties together by footprint all the areas, and by default it gives the average values wherever things overlap. So overlaps don't cost you anything. So that's a VRT, and this VRT that I just created, I could add it to QGIS, QGIS will want to draw it immediately. Since this is equivalent to about 100 gigabyte file, it would take a while to draw. So you would uncheck this render box right down here if you wanted to do immediate analysis on it with the point cloud, the point sampling tool right there. So in any event, that's the point sampling tool. That's VRTs. VRTs are very useful. In fact, since Google has been part of the Esri build library since ArcMap 9.2, you can read VRTs directly into ArcPro if that is what you need. So you have just like a GeoTiff, you have a raster format that can be used in both the Esri world and the open source world. And that's all I have for right now. If you have any questions, just go back to the beginning of the video and you can see my email and shoot me an email. Thank you very much.